So we're looking at the preparatory. This is a partial derivative. Question 1, you have function of x, y, z and finds only del f, del x, del f, del z. So for the partial derivative, when you differentiate respect to x, okay, y and z are constant. So when you differentiate respect to z, x and y are constant. Then you need to get all your techniques of differentiation that you have learned in calculus or engineering mathematics 1. So for question A, del f, del x. So okay, basically you have your f, okay, so f, x, y, z is z ln xy plus y sin xz plus z exponent xy. Ln xy, you can actually ln, using the logarithmic formula, multiplication, it becomes addition. So you have the z ln x plus y sin xz plus z exponent y. So you want to find del f, del x, del f, del x. Okay, exactly you del x the f. Differentiate your f here. So mean you del x, okay, you have 1 term, 2 term, 3 term, so you del x. It's z here, the ln, okay, I break it become ln x plus ln y. Plus you del x, y sin xz. Plus you del x, the third term, which is z exponent xy. So when you del x, y and z are constant. So this one z is constant, okay. You can here you can factor out the z, so you got z, and then this is del x. This becomes del x your ln x plus ln y. Okay, and then when you del x, y is constant, so you can factor out this y, so you have plus y, and then you del x, your sin xz. So when you del x, z is constant, so you can factor out your z here. So it becomes z del x exponent xy. Okay, after that, okay, here, so z del x ln x, okay, you have 1 over x. This is 1 over x. Okay, del x ln y is 0 because ln y is constant. Differentiate a constant, you get 0. Y. Okay, del x sin xz. Okay, sin xz, where the z is a constant. Z is a constant. So you will get sin xz, z is constant. For example, like your z is 3. Like you del x sin 3x, okay, you will get, this will be 3. This is z and not 3. You will this one to be z cos xz. In delta x sin xz, z is a constant value. Okay, for example, if you ddx sin 3x, okay, the answer will be 3 cos 3x. So, but this is 3. But in this case, z here is equivalent to a constant number. That's why you get z cos xz. Okay, and then later on, delta x exponent xy. Okay, delta x exponent xy, you will get, example, if you ddx exponent, let's say pi x, the answer is pi exponent pi x. So that's why, okay, where the y is equivalent to pi here, that's why you get zy exponent xy. So the answer, you have z over x plus yz cos xz plus zy exponent xy. Okay. Okay. Any questions here?
No.
So if no, can you similarly do for your del f del y? Del f del y, you just change the delta x here to delta y. Okay, if del f del y, if del f del y, I need to change here. This one become y. Del f del y, this is del del y, this is del del y, this is del del y. When you del del y, x and z are constant. So again, del del y z is constant. So you factor out z. So this is a del del y. Del del y, del del y, del del y. Okay. Del del y is z constant, factor out z. So del del y ln x plus ln y. Okay, when you del del y, okay, sin xz is constant, so you factor out sin xz. So when you del del y, this term don't have okay, y, x and z is constant, so you factor out. So you factor out, sin xz is a constant, then you just del del y, y. So the third term, del del y, z exponent xy. So z constant, so factor out z. So del del y exponent xy. Okay, for this first term, del y ln x will be 0. Exact. Del y ln x, this will get 0. Del y ln y is 1 over y. Okay. Del y you have 1. And so here you get sin x sec. Okay. And then question 1 delta z. Never mind, this one do delta y first. So last sec, and then delta y exponent xy. Okay, when you delta y, x is constant. When you delta y, x is constant, so you have z x exponent xy. Okay. So if ddx exponent phi x, phi exponent phi x. So the same thing if you dy exponent phi y, the answer is phi exponent phi y. Where x is equivalent like a constant value, let's say it's phi, that's why you get x exponent xy. So this is for del f del y, where you have z over y plus sin x z plus sec x exponent xy. So for delta y, is it okay? But the question 1 is a del f del z. Del f del z. Del f del z is actually del z, the f, which is z, ln xy break it become ln this one I don't break it because okay, the z ln xy is okay, ln xy is constant. And then plus del z y sin xz plus del z z exponent xy. Okay, when you del z, xy is constant, that's why the whole term ln xy is constant. So you can factor out ln xy. So you have ln xy, okay, ln xy, and then del z, z. So when del z, y is constant, you factor out. But this one, you have a great z, sin x z is function of z, that's why cannot be factored out. So when you del z exponent xy, this is constant, can be factored out. Okay? So plus y cube del z sin xz, okay, plus exponent xy del z z. So del z you have 1. So the answer you have ln xy. Okay, del z sin xz. Okay, when you del z, x is a constant. Okay, x will factor out. So you get here is actually xy cos xz. Remember, okay, here if you ddz, let's say sin, okay, phi z. The answer is phi cos phi z. Okay, where the x is equivalent to a constant, let's say is phi. That's why you get phi cos xz. Plus, okay, del z is 1. That's why here you just get answer exponent x1. So this is a del f del z. you get the answer ln xy plus xy cos xz plus exponent xy. This is for del f del, this is del f del y. So this is for question 1. Okay. Any problems? Okay, who face difficulty, please raise up, voice up now. Because if you cannot do partial derivative, later on you can do your chain rule. And then you cannot do your implicit differentiation and you face difficulty to do your projects. Because the big use of the partial derivative.
Got it.
So question 2, the same thing, only change sin to cos, ln xy to ln x divide y. The third term same. So means f, okay, your f x y z we read k, right, k as z ln x minus ln y plus y cos xz plus z exponent xy. So A, you want to find del f del x. Okay, del f del x. So you del x the f. Where the f is here. Z ln x minus ln y. Okay, plus you del x y cos xz. Okay, plus you del x z exponent xy. So when you del x, z is a constant. When you del x, z and y are constant, but here z multiply this one. See? So in the product form, your constant can be factored out. So product form. Okay, in the product form, a constant can be factored out. So when you del x, y is constant, so you factor out the y. So in the product form, z is constant, so z can be factored out. So if you got plus k or minus, then you del x each of the term. But in product form, so you have to locate which one is a constant, factor out the constant. So you factor out z for the first term, so z, and then you del x ln x minus ln y. So factor out y, okay, you have y, and then you del x cos xz. Factor out the z, and then you del x exponent xy. Okay, delta x ln x is 1 over x. Delta x ln y, where y is constant. So delta x a constant, you have 0. So delta x cos xz, where the z is constant. Z is constant. Look, factor out here. So you have y z. Okay, remember differentiate cos is negative. That's why you have negative z sin xz. Cos it here. Remember, if you ddx, say cos 2x, the answer is negative 2 sin 2x. So your z here is equivalent to, let's say, a constant value. So differentiate cos negative sin xz, where the z is constant, that's why constant. Or differentiation, you bring in front of the sin term, or mean multiply. If division, if integration, then our constant will become divide. So that's why here you get negative delta x cos xz. The answer is negative z sin xz, similar to here. And then delta x exponent xy, the answer will be z y exponent xy. Cos here, you have to tally back ddx exponent, let's say 2x. The answer is 2 exponent 2x. So the y here is equivalent to a constant value. That's why delta x exponent xy, you got y exponent xy. So this is the answer. Okay, so you z over x minus yz sin xz plus yz exponent xy. This is for del f del x. Okay, and if you want del f del y, del f del y, so you have to delta y the f, so the f which is z ln x minus ln y, if plus you delta y cos xz plus delta y z exponent xy. So when you delta y, x and z are constant. So z here, factor out, delta y, so cos xz, when you delta y, x and z are constant. So cos xz is a constant, can be factored out. Delta y, z is constant, so factor out the z. That's why you get here this z. Then you delta y ln x minus ln y, okay, plus cos x is constant, so factor out cos xz, and then you delta y, okay, plus z, then you delta y exponent xy. So when you delta y ln x, the answer is 0. Okay. Delta y negative ln y is negative 1 over 1. Okay, so delta y you have 1, so plus cos xz. Okay, delta y exponent xy, you got z. Okay. For this one is x exponent xy. So the final answer is negative z over y plus cos xz plus xz exponent xy. So this is a del f del y. And if you want del f del z, then you del z, z Because ln x minus ln y, I can combine back, become ln x divided y. Because this term is constant value delta z. Ln x over y. Ln x, okay, x divided y is equivalent to ln x minus ln y. Because the whole term here is constant value delta z. That's why I combine back. And then plus delta z y cos xz plus delta z z exponent xy. So when delta z ln xy is constant, this is constant. So factor out constant. So you have the ln xy. Then you just delta z z. Okay, when you delta z y constant, factor out y. Okay, this one got function of z, so it cannot be factor. So y delta z cos xz. Okay, when delta z exponent xy is constant, so factor out. So plus exponent xy delta z z. This one you have delta z z. This one you get 1. This one you get answer is 1. That's why you have ln x over y, okay, plus y. Okay, delta z cos xz, you have negative x sin xz. So plus exponent xy. Okay, that's why the answer is, nicely, ln x over y. Okay, this is y multiply negative x sin xz, so become negative xy sin xz plus exponent xy. Any questions here? Similar to question 1. Only the sin change to cos. Okay, ln x divide y, initially is x times y change to x divide y. So as long as when you delta x, treat y, z constant. When you delta y, treat x and z constant. When you delta z, treat your x and y constant. Okay, the constant term, if in product form, you can factor outside of your the partial derivative operator there. Question 1, 2. Question 3. Okay, determine the first partial derivative of the following functions. Okay, the first partial derivative, so means just determine del f, del x, del f, del y, del f, del z. First one, del f, del x, or can be read or fx. So it's actually you del x, x squared y cubed z plus delta x, the second term, x power 4 y z squared plus delta x z. So when you del x, y cubed and z constant. These two terms constant and in product form, then factor outside of your del x. When del x, y, z squared constant, factor outside. So del x, z constant, so factor out. Here you have got y cubed z, and then del x, x squared, plus y z squared, del x, x power 4, plus z, del x, x. So we have y cubed z, del x, x squared is 2x, so y z squared, del x, x power 4, you have 4x cubed. Del x, x is 1, and then we write it in a nice form, 2x, y cubed z. We put x, y, z in the sequence. So plus 4x cubed y z squared plus z. So this is a question 3 part A. In polynomial, you're easy to do your polynomial. This is only polynomial function, then easy to do your partial derivative. Compared to you've got log or the square root functions or exponential function. And then for your first partial derivative, then you have your del f del y. And change the delta x to delta y. So it's the same step. Only now when you delta y, x and z are constant. So delta y, x power 4 y z squared plus delta y x z. When delta y, x and z constant, so you factor out the constant where I highlight with a yellow color. So x squared z factor outside. When the delta y are these two constant factor out. So y is not. Delta y only x power 4 z squared constant factor out. Delta y, so this is totally constant. Delta y constant you have 0. So factor out x squared z, then delta y cubed. Factor x power 4 z squared, so x power 4 z squared, then you delta y. Delta y constant, so 0. So you have x squared z, delta y cubed, so it's 3y squared. 3y squared. Delta y, you have answer is 1, so this is x power 4 z squared. So we write the answer in the nice better form, 3x squared y squared z plus x power 4 z squared. So this is del f del y. Del f del z. So change delta y to delta z. Delta z x squared y cubed z plus delta z x power 4 y z squared plus delta z x z. When the delta z here, these two constant, del del z, x power 4, y is constant, factor out. Okay, del del z, x is constant. Then you factor out x squared y cubed, and then you del del z, z. Okay, plus x power 4 y, and then you del del z, z squared. Factor out x, so and then you del del z, z. X squared y cubed. Del del z, z is 1. Plus x power 4 y. Del del z, z squared. We have 2y. Del del z, z is 1. There's only plus x. Okay. X squared y cubed plus 2 x power 4 y squared plus x. So this is a question 3a.
There is 2z, right?
Your F del z. Which term?
Del z, z square turn to z, not to y, right?
Oh yeah, 2z. The z squared 2z, correct? This is the z squared 2z. So 2x 4y z. So the answer is 2x power 4 y z. The z squared is 2z. So this is question 3a. So this is 3b. So find the first k partial derivative. Then find del w del x. Del del x y exponent z sin x z. Okay, when del del x y exponent z is constant, these two constant, factor out. So you have y exponent z, then you del del x sin x z. Y exponent z. Okay, del del x sin x z, you have it where the z is constant. So you got it, the answer z cos x z. You just treat the z like let's say 2. The x sin 2x, you got 2 cos 2x. That's why you put here. If you want del w del y, so it's del del y exponent z sin, okay, sin x z. Okay, when del del y, okay, exponent z is constant, okay, sin x z also constant, because don't have the y term. Then you can factor out. To factor out the constant term, so you have e exponent z sin x z, and then you del del y, y. Okay, del del y, answer is 1. That's why the answer is exponent z sin x z. Later on for del w del z. Del w del z. Okay, del w del z will be del del z delta z y exponent z sin xz. So when the delta z y constant, this is exponent z, function of z. This one is function of z. So you can only factor out y. So you got y delta z exponent z sin xz. Okay, now you notice exponent z multiplied with sin exponent z is in product form. Both term consists of sec. So that's why in this case you have to use a product rule, treat this as a u, this as a v. Right. We have treat the u is actually exponent sec, v is sin xz. Then you want to find del u del sec. You get exponent sec. Del v del z, where x is constant, as we have x cos xz. And the product rule, the result is u v prime plus v u prime cos. That's why you have y exponent z multiply x cos xz plus exponent z multiply sin xz. So this is the answer. If y and then cos y constant here you factor out, this is u v prime plus v u prime, or v u prime here. So this case, you have to use product rule because exponent z multiplies sin xz. Okay, both are function of z, cannot be factored out. You can only factor out y, but here is a product form, that's why use the product rule. Use product rule. So it's okay, question 3b. Question 4. Question 4, given the fxy is ln square root x squared plus y squared. This one, you can change it become ln square root is x squared plus y squared power half. Using logarithmic formula, this one become half ln x squared plus y squared. Power half we can bring in front of the ln. So it will be easier, you simplify the ln functions using the logarithmic formula. Then you can easily differentiate it. So ln square root x squared plus y squared can be changed to half ln x squared plus y squared. Then find fx, fy, fxx. Get the fx is actually your del x, the f, where the f is half ln x squared plus y squared. The half is constant and factor out, so it's only half, okay, delta x ln x squared plus y squared. Recall back, okay, when you ddx, ln u. The answer is 1 over u du dx. So now your u is x squared plus y squared. So you have half 1 multiplied 1 over x squared plus y squared, where the x squared plus y squared is equivalent to u here. So you have 1 over u. And then del x squared plus y squared. Half of x squared plus y squared. Del x squared plus y squared, your answer is 2x. So you simplify it, so that's why you get the answer is x over x squared plus y squared. So this is for fx. Similarly for your fy, fy it will be fy, you just change delta x to delta y. So you have actually y over x squared plus y squared. This is delta y half of ln x squared plus y squared. So it's half delta y ln x squared plus y squared. So it will be half multiplied 1 over u, where the u is a x squared plus y squared. And then delta y x squared plus y squared. So you get half x squared plus y squared. Okay, delta y x squared is 0. Delta y squared, answer is 2y. So simplify, okay. 2.5 here. The answer is y over x squared plus y squared. So this is a fx, this is a fy, fxx. Fxx is actually delta x fx. Fxx is delta x fx, which is delta x over x squared plus y squared. Okay, so now you have to, you want delta x, you see numerator function of x, denominator function of x, then in this case you have to use the quotient rule for differentiations. So this one, delta x over x squared plus y squared, with 4 back scale. If your ddx u over v, the formula is v u prime minus u v prime divided by v squared. So use this formula, the quotient rule. Okay, so now your fxx where the v is actually x squared plus y squared. this is a b. B is a denominator, and then you del x the u, which is x. Okay, minus a u, which is x. Okay, del x the b, which is x squared plus y squared, divided by b squared, which is x squared plus y squared. So this is u, this is v prime minus u v prime. Delta x is 1, that's why you have x squared plus y squared, okay, minus x. Delta x squared, you have 2x. Delta x y squared is 0. So divided by, this is power 2, x squared plus y squared here, power 2. Simplify, so we have y squared, x squared minus 2x squared become minus x squared divided by x squared plus y squared power 2. So this is a question 3, part 1. Question 4. Okay, question 4, determine the partial derivative of fx, fy, fxx. Okay, part 2, analyze the relationship between second order partial mixed derivative fyx and fxy. Okay, fyx will be always equal to fxy. So first of all, this is fxx. So we want to find fyx. Fyx is actually from fy. You del x. This is from here. And after you get fy, differentiate respect to x. So it's actually del x the fy. Fy just now that we obtained is here. Y over x squared plus y squared. So against K for here, you have to apply the product, apply the quotient rule. You have your y, because you have your y, numerator function of y, denominator also function of y, that's why you have to apply your quotient rule. Hence, you have the v x squared plus y squared. Okay, u is numerator, so you have to del y the y minus the u, which is y, and then del y the v, which is x squared plus y squared. Okay, divided by v squared. Which is x squared plus y squared power 2.
Okay.
This one is fxy, sorry. Del x fy. This one notation should be what I do. fxy is actually fyx. Fyx, correct. From fy differentiate respect to x, and then del y. Oh, this is del x. This one del x. Del x, del x, del x. Fyx is actually from fy and then after you get fy, you differentiate respect to x. So this is del del x. This is u, the denominator is v. So you got v u prime. That's why I have to del del x and y minus u v prime. So del del x v divide by v squared. Okay, del del x y, del del x a constant, you have this one 0. So the first term gone. Del del x squared plus y squared, you got 2x. Del del x y squared is 0. So you got negative y 2x. So divided by x squared plus y squared power 2, or negative 2xy divided by x squared plus y squared power 2. So this is a fyx. Okay, later on when you find fxy, will always equal to fyx. Okay, this one fyx. Later on we find fxy. Okay, fxy is actually from fx, okay, and then you differentiate respect to y. So it's del del y fx. Okay, fx that we obtained just now is x over x squared plus y squared, which is del del y x over x squared plus y squared. So again, we can use K quotient rule, where this is u, K denominator is v, then you have v, which is x squared plus y squared. U prime here is actually with del del y, the x, okay, minus u, which is x, and then del del y v, which is x squared plus y squared. Okay, and then divide by v squared, which is x squared plus y squared power 2. Similarly, del del y x, this will be 0. So the whole first term become 0. Del del y, this one 0. Del del y squared is 2y. So you got negative 2x y divided by x squared plus y squared power 2. So that's why, okay, you can see, okay, fxy is always equal to fyx. Therefore, fyx will always equal to fxy. Okay, f of fyx is from fy, later on differentiate respect to x. Fxy is from fx and then differentiate respect to y. And they are always fyx equal to fxy. So straight up to question 4. So, any questions here?
No.
So already question 4. Question 5, first partial derivative. So you have W is function of x, y, z equal to y exponent z sin x z. Want to find the first partial derivative, so it's del W del x, which is del del x W, which is given by y exponent z sin Okay, sin x z. Okay, when you delta x, y and z are constant. So this one constant, y constant. So this is function of x, that's why, okay. So you factor out y exponent z. So you have y exponent z, factor out. So you have delta x sin x z. Okay, delta x sin x z, you got z cos x z. And y connect together, y z exponent z cos x z. This is a del w del x. In del w del y is del del y exponent z sin x z. So when del y exponent z is constant, sin x and z constant. So these two terms constant, so it can be factored out. So you factor out exponent z sin x z, and then this becomes del y y. Del y y, the answer is 1. That's why you get exponent z sin x z. Lastly, your del w del z. Del w del z is your del z y exponent z sin x z. When delta z y is constant, this one you got exponent z, this is sin exponent z, is in product form. That's why after you factor out the y, you have to apply the product rule. So you have y and then delta z exponent z sin x z. Where you have q is actually your exponent z, v is actually your sin x z. So you want del z. So this will be del u del z. You get exponent z. This will be del v del z. You get x cos x z. So product rule, you have u del v del z plus v del u del z. That's why your answer is y multiply exponent z x cos xz plus exponent z multiply sin xz. So up to question, this is question 5, is it? Question 5. I think question 6 is that no problem, right? Question 6.
No.
Question 6, no problem. Question 7. If z is a cos, okay, 4 over x multiply exponent x squared y minus 5y cubed, find del z del x and del z del y. So you want del z del x, you del x cos 4 over x This one apply the product rule. Where the u is actually cos 4 over x. If v is exponent x squared y minus 5y cubed. So we want del x, so this will be del u del x. Okay, del u del x. Differentiate cos, okay, you have negative sin 4 over x, and then you have to del x, okay, del x 4 over x. So del x 4 over x negative 4 over x squared. So this will be negative, so positive 4 over x squared sin 4 over x. Okay, this for del u del x. So okay, del x 4 over x. Is it okay? It become 4x power negative 1. And then for del v del y, del v del x. This one, okay. Differentiate exponent, you have the exponent, okay, the same form of the exponential term. Exponent x squared y minus 5y cubed. And then you have to del x, okay, the power for your exponential term, del x, x squared y minus 5y cubed. That's why del x, x squared y, you have got 2xy, del x, negative 5y cubed, the answer is 0. That's why you got, the answer is 2xy exponent x squared y minus 5y cubed. Then after you apply product rule is u multiply del v del x. It will be your 2xy cos 4 over x multiply exponent x squared y minus 5y cubed. Okay, plus we multiply del u del x. So plus this one 4 over x squared sin 4 over x, okay, multiply here v, which is exponent x squared y minus 5y cubed. Okay, this one cos del x, cos 4 over x, function of x, exponent here, you also got function of x, and in product form. That's why you have to use a product rule. Treat the u as a cos 4 over x, v at exponent x squared y minus 5y cubed. Then del u del x, differentiate cos, you have negative sin with the same form. And then you have to del x 4 over x. Okay, when you ddx, your 4 over x is actually like your ddx 4x power negative 1. So you got negative 4x power negative 2, which is negative 4 over x squared. 4 over x is actually 4x power negative 1. So for differentiation, the power negative 1 will times 4, which is negative 4. And then x power negative 1 for differentiation, the power will decrease by 1. So become negative 1 minus 1. So it's x power negative 2. So negative 4 x or negative 2 is negative 4 over x squared. So okay, we'll prefer the constant you write in front of the sin term, so you won't confuse. So this is a constant. Okay, write in negative, negative, positive. So 4 over x squared times of sin 4 over x. Differentiate exponent term, okay, delta x exponential term, you will get back the same exponential term. However, you have to delta x the power of the exponential term. So delta x squared y, here you got 2xy. Delta x negative 5y cubed is 0. That's why you got 2xy exponent x squared y minus 5y cubed. So put down, okay. Later on, u times del v del x, which is okay. I take this term first, then time here, plus v times del v del x. So I write this term first, and then here. So this is a question 7 for del z del x. And then del z del y. Okay, if del z del y, you del y cos 4 over x exponent x squared y minus 5y cubed. Okay, when delta y cos 4 over x is function of x, which is constant. Okay, delta y. So cos 4 over x is constant. So that's why this time you can factor out cos 4 over x, because this term is constant. So for delta y, you no need to apply product rule. So you got here cos 4 over x. So delta y exponential term, you get back the same exponential term, which is exponent x squared y minus 5y cubed. And then you have to delta y the power for the exponential term, which is x squared y minus 5y cubed. Okay, so you have cos 4 over x exponent x squared y minus 5y cubed. So delta y x squared y, okay, you get x squared. Okay, delta y negative 5y cubed, we got negative 15y squared. So this is the answer for your del z del y. Cos 4 over x exponent x squared y minus 5y cubed times x squared minus 15y. So up to questions 7. Okay, and then now you can go to your author. Okay, go to your author. Since you have no question, so let you do one quiz. Okay, you go to the author assessment there. Okay, you should be able to see the quiz one by now.